went. If there were any last questions from chapter 1, I'll take those this morning. And then I'm going to go through chapter 2 with you. And by the end of the session this morning, I will put on I'll put up the assignment from chapter 1 that you can do for the next couple of days. So were there any questions from chapter 1 that you would like done this morning from that review? All good? Okay. All right. So perfect. If there's no questions, then let's do a quick look and see what was in chapter 2. So let's go to page 103 this morning. So we'll start with page 103. Okay. So the first thing we did in chapter 2 was learn how to convert. Well, not really convert. Let's start with it talks about angles in standard position, terminal angles or coterminal angles, and what a reference angle is. So let's go through all of that right now. Okay, and the reason we do all of this is again because what we learn for when we use the sine law is that when we take the ratio for the sine of 30 degrees and the ratio for the sine of 150 degrees, they gave us the same value. So when we use the sine law, it's important that we understand where it all comes from. So first things first, a reference angle. A reference angle is any angle that is found in the first quadrant is considered the reference angle. All right. So when we do our second function sine, second function cos, second function tan of a positive ratio, it will always give us an angle in the first quadrant. Okay. And we refer to that as the reference angle. A coterminal angle. A coterminal angle is an angle that's in the exact same position. So how do I find that? Well, let me use an example to show you. Let's say my reference angle is 30 degrees. A coterminal angle is an angle that would go either all the way around that way and end up back in the same spot, or in the reverse direction and end up in the same spot. So how do I find anything that's a coterminal angle? I either add or subtract 360 degrees to that angle, and that gives me what we call a coterminal angle. Now, all of this is not as important in the grade 11 course as it will be in the grade 12 course. Okay? But we do need to know all of this, and we do need a starting point. So this is where they start you off for it. So to get a coterminal angle, I take whatever angle it is I'm talking about in standard position, okay? And I'll talk about standard position in a second. And I add 360 or subtract 360 to get it. So in this case, my next one would be 390 degrees or minus 330 degrees, exact same position. An angle is considered in standard position if you start along the x-axis and you go counterclockwise. And it doesn't matter where it is, I'm just drawing it hypothetically, but an angle in standard position means that you start with this is called the terminal arm, and the terminal arm rotates around your axis here, okay? So this angle is considered in standard position. Another thing that we looked at was the quadrants, okay? So quadrant 1, 2, 3, and 4, okay? So to begin with, that's kind of where we're at with 2.1. All right. Sketch an angle in standard position of 35 degrees. Okay, well, let's look at that. Again, I start with the positive x-axis and I work my way backwards or in the opposite direction. So I would say the reference angle is 35 degrees. That's drawn in standard position. 165 degrees would be starting here and end up somewhere over there. That angle then being 165 degrees. Okay. Exact values. Okay. So this was one part two. Again, this is not as important in the grade 11 course as it is in the grade 12 course. This is a massive thing for the grade 12 course. It says determine the exact value of the following ratios without using technology. So there's quite a bit here. I'll go through it real quick here. But I have what we call the unit circle right there. And on the unit circle, we went about labeling all of the ratios for all the different angles for 30s, 45s, and 60-degree angles. Okay, so you'll remember this at some point. All right, so right here I had 0 degrees. And that was, because it's a unit circle, that's 1 and 0. Right here is 30 degrees. The sine of 30 degrees is a half. We have to remember that. And the cos is √3/2. Okay? So again, I'm going through this quickly. I understand you probably don't remember some of this. 45 degrees, but we didn't do a lot with this anyways. All right? Because, like I said, the focus for this is just to introduce it, and we do it in grade 12. So the 45-degree ratios are √2/2 and √2/2. The 60-degree ratios, I'm making a mess of this. The 60-degree ratio is 1/2 and √3/2. So it's the same ratios as these guys. 30 and 60 are the same. Why is that? The ratios all come from this triangle right here. A 30, 60 degree, 30, 60, 90 degree triangle. We remember that at all times the sine of 30 degrees is 1/2. That makes this √3 by using Pythagoras' theorem. So the sine of 30 is 1/2. The cos of 30 is √3/2. The tan of 30 is 1/√3. The sine of 60, √3/2. Cos of 60, 1/2. Tan of 60, √3/1. Okay, so all of these we labeled all the way around this triangle. This right here, these ratios stay the same all the way around depending on the reference angle. So for example, I'm going to use 150 now. So 150 degrees. Well, the reference angle is the same as 30 degrees because that's the angle it makes with the horizontal axis. So 150 degrees has the same ratio as that, except the cos is a negative. Because in quadrant 2, my x values are negative. All the ratios the cos are the x, the sine is the y. All right, so that's 2.1. Again, it's not a big deal, but it would help you to refresh this because in grade 12, we need to go through this very significantly. So this is how this works, okay? And then I could go all the way around the triangle. The ratio or the circle, the ratios are all the same. The only thing difference is I add negatives depending on what quadrant it is in. So that was 2.1. Okay, now there was quite a bit there, but like I said, I'm not too caught up on it. Now, 2.2 is a point -4 and 5 lies on the terminal arm of the angle. Okay, so in 2.2, I have the coordinate -4 and 5, which is somewhere up here. So that makes this -4 and this 5. Okay, so I draw that out. My angle again is always made with the horizontal axis. The angle, depending on the quadrant, the angle is always made with the horizontal axis. So the first thing I need to do is I need to find out what this is. So that is the square root of, so 16 and 25, so that's the square root of 41. And then it asks you to find sine, cos, and tan. So what's the sine of theta, the cos of theta, the tan of theta? Sine theta, 5 over root 41. Cos theta, -4 over root 41. Tan theta, 5 over -4. All right. So a point -4 and 5 lies on the terminal arm of the angle theta in standard position. Determine the exact trig ratios for sine theta, cos theta, and tan theta. Well, those are my ratios. Now, I'm not asking you to find the angle. All I'm asking you to do is find the ratios using the triangle. So that was a start at 2.2. You would do the same in question 4. Question 5. This is the one I want to get to. Again, not as major for grade 11, but huge for grade 12. So here's this. I'm going to show you how this works. It asks you to solve for theta, so find an angle between 0 degrees and 360 degrees for the following ratio. So I'm going to use this ratio right here. Cos theta equals negative, let's make this a little bit neater, negative 0.123. Okay, so I want to find all of the angles between 0 and 360, so all the way around this circle here, in which the cos ratio is negative 0.123. So the first thing I'm going to do is find my reference angle. So in the first quadrant. So I need to use my calculator right here. And when I do second function cos of 0.123, I am not putting in the negative. I'll explain that in a second. So I'm putting in, to find this, I use cos negative 1.123. Enter. So my reference angle is 82.935 degrees. All right. Again, so I use the positive ratio, not the negative here. Now, I ask myself, what two quadrants is cos negative in? Now remember, cos represents an x ratio. So where is cos negative? What two quadrants is cos negative? Quadrant 2, quadrant 3. That's where my cos is negative because that's where my x is negative. So I want to find out, first things first, what this angle is right here. So I write theta 2, quadrant 2, just to show that it's in quadrant 2. And I need to find out what this angle is. Well, because I know my reference angle here, and all the way from here to here is 180 degrees. In the second quadrant, I find the angle by taking 180 degrees and subtracting my reference angle. So I take 180. So if you were to punch into your calculator, I think I cut out. If you were to punch into your calculator the cos of 97.065, you would get the ratio to be minus 0.123. So there's the second quadrant. But cos is also negative in the third quadrant. So I need to find this angle right here. Again, I know my reference angle. My reference angle is 82.935. So to get this angle, I add the reference angle to 180 degrees. So I take 180, I add 82.935, and I get 262.935 degrees. So again, the question starts like this. For what value of theta is the cos ratio, meaning the side adjacent over the hypotenuse? So if I were to draw a triangle, that's what I would get as my ratio. Now remember, when you do trigonometry, you can write the ratio as a fraction or as a decimal. Okay? In this one over here, in this question, I wrote all my ratios as fractions. But 5 divided by root 41 would give me a decimal. So if I wanted to find out what theta was, I would take second function sine 5 divided by root 41. Okay? So this is how the question starts. The first thing I do is find my reference angle. That means I find the second function cos, but not as a negative, as a positive. The reason I find my reference angle is it helps me find these two. So in this quadrant here, to get the angle, I add 180 to my reference angle. In this quadrant, you'll remember, is 360 degrees, subtract the reference angle. Now the reason I don't have anything in quadrant 4 is because cos is positive in quadrant 4. All right, so I don't need the ratio here. The ratio is a negative 1.123, so I find those two. Now, most of the time, the error comes in the fact that you would punch in second function cos negative 1.23 in your calculator. And that's great because it would give you this angle right here. It would give you 97.065. But then you would stop there. And that's no good. Because there's two spots between 0 and 360. There's two angles that when you take the cos of them, that will give you the ratio of minus 0.123. Okay? So those two angles are 97.065 and 262.935. Okay, so do some, I didn't do anything out of the book. I left you 5A and B to do on your own, but that's a big part of it. Now again, hugely important to grade 12. We do a lot of work in grade 12 with this right here. So we want to make sure that we hammer it out right now. And then the last two things that we need to do is your law of sines and your law of cosines. Okay, so law of sines, we've done so much with it in this course and the applied course that I don't think I need to go through it. I'm just going to set it up quick. But what it says is that if you take the ratio of the side and the angle across from it, they should all equal each other. So if I take the measurement of side A and I divide it by the sine of angle A, and do the same for B and sine B and the same for C and sine C, I'm going to end up with the exact same answer in all three cases. They all equal each other. All right. Now where I use this is when I'm given a side and an angle across from it, and the triangle itself is not a right angle triangle. If it's a right angle triangle, you use sine, cos, or tan. But there's no right angle here. And I have to have an angle and a side across from it, those measurements. If I don't have an angle and a side across from it, then I need to use my law of cosines, which is 2.4. And the law of cosines is a squared equals a squared plus is equal to b squared plus c squared minus 2bc times the cos of a. All right, so that's your 2.4. But again, I don't want to spend time on them, mostly because you have done so much work with it in this class and on the applied. Okay, so I think the part that's going to give you, or at least you're going to have to look at the closest, will be 2.1 and 2.2. Because I think 2.3 and 2.4 you'll kind of sail through it. There aren't a lot of questions in the review, which is fine. So it takes probably a day, maybe a day and a half, just to kind of go through it all. All right. I went through it real quick. Any questions, concerns, comments from the first part of this on 2.1 and 2.2 or 2.3 and 2.4? Anybody have any issues here this morning? Okay. So I will post. Sorry, just checking to see who's on here this morning. I will post the assignment right away for chapter 1. And like I said, I'll set it as a due date for Monday. Today's being Thursday. Yeah, I'll set the due date for Monday. The sooner we can get these in, we're already into June on Monday, so you're going to have a little bit less time as we go here to get some of these assignments done. I'm giving you Monday because this one's a little bit longer, but like I said, if you can hand that thing in, just going to exit out of YouTube.